Welcome to the MOTO Freak Channel. Greetings to all viewers, subscribers, supporters. So to the point. The Fiat 1.4 Multiair engine is a fascinating piece of automotive engineering, taking the established 1.4 T-jet fire architecture and adding an innovative electro-hydraulic valve actuation system. This technology aims to optimize combustion for improved performance, fuel economy, and emissions. However, its complexity also introduces specific considerations for maintenance and potential issues. History and versions. Introduction. Fiat Powertrain Technologies, FPT, launched Multiair technology in 2009, initially appearing in the Alfa Romeo MOTO. It was a significant breakthrough in petrol engine design. Basis. The 1.4 Multiair is built upon the same 1.4-liter, 1,368 cubic centimeters, fire, fully integrated robotized engine, base as the 1.4 T-jet. The key difference is the replacement of the conventional intake camshaft and fixed cam lobes with a Multiair hydraulic valve actuation system. Power outputs. The 1.4 Multiair has been offered in various power outputs, typically ranging from 105 HP, naturally aspirated, to 190 HP, turbocharged, depending on the application, e.g. Fiat 500, Alfa Romeo MOTO and Giulietta, Jeep Renegade and Compass, Fiat 124 Spider, Dodge Dart. Evolution. While the core Multiair concept remained, there have been refinements over the years, sometimes referred to as Multiair 2, which aim to improve reliability and efficiency. Later Multiair 2 engines, like those in some Jeep and Dodge models, also incorporated direct fuel injection, a significant departure from the earlier indirect injection versions. Key characteristics: 1.4 Turbo Multiair. Engine layout: inline 4-cylinder. Displacement: 1,368 cubic centimeters, 1.4 liter. Valves: 16-valve DOHC, but with a multi-air system controlling intake valves. Fuel delivery: primarily multi-point injection, MPI, for earlier and most common versions. Some later Multiair 2 engines, e.g., in some U.S. market vehicles, utilize direct injection, DI. This is a crucial distinction regarding carbon buildup. Valve control, the defining feature. It uses an electro-hydraulic system to precisely control the opening and closing of the intake valves, allowing for variable valve lift, timing, and duration independently for each cylinder. This effectively replaces the throttle body in terms of air control, reducing pumping losses. Block material: cast iron. Head material: aluminum. Timing belt. Review and opinions. The 1.4 Multiair engine is lauded for its theoretical benefits and often delivers on its promises of performance and efficiency. Advantages: improved performance and torque. The precise valve control allows for optimized air intake, leading to better low-end torque, up to 15% improvement, and increased peak power, up to 10% improvement, compared to conventional engines of similar displacement. This translates to a more responsive and enjoyable driving experience. Enhanced fuel efficiency. By virtually eliminating pumping losses, no throttle plate restriction for air intake, and optimizing combustion, Multiair engines can achieve notable reductions in fuel consumption, up to 10% in some cases. Reduced emissions. The ability to finely tune air intake helps reduce CO2, particulate matter, and NOx emissions. Dynamic response. The system allows for very quick and precise control of air mass, leading to excellent throttle response and a more engaging feel. Compact design. The Multiair system can be integrated into existing engine designs by replacing only the cylinder head, making it relatively compact. Disadvantages. Complexity. The electro-hydraulic Multiair unit is a complex piece of machinery. This complexity can lead to higher repair costs if it malfunctions. Sensitivity to oil quality and maintenance. This is the biggest disadvantage. The Multiair unit relies heavily on clean, correct specification engine oil to function properly. Improper oil type, extended oil change intervals, or low oil levels are primary causes of Multiair unit failure. Cost of Multiair unit replacement. If the multi-air unit fails, it is an expensive component to replace. Potential for turbo issues, like T-Jet as it's a turbocharged engine. It shares the general turbo-related concerns of the 1.4 T-Jet, though multi-air unit issues tend to overshadow these. Common faults and breakdowns. The overwhelming majority of reported issues with the 1.4 Multiair engine revolve around the multi-air unit itself. Multi-air unit failure. Symptoms: loss of power, rough idling, engine misfires, often cylinder 1 or 4. Check engine light illumination, metallic ticking noises from the top of the engine, especially when cold. Causes: incorrect or contaminated oil, the most common cause. The multi-air unit's tiny hydraulic passages are highly sensitive to sludge, carbon deposits, or oil that doesn't meet the precise specifications. Viscosity, additive package. Lack of oil changes. Extending oil change intervals allows contaminants to build up and the oil to degrade, directly impacting the multi-air unit's operation. Low oil level. Insufficient oil can lead to air in the hydraulic system, causing misfires and damage. Microfilter clogging. The multi-air unit has a small oil filter, or screen, that can clog, starving the unit of oil. Some mechanics recommend cleaning or replacing this with every oil change. Solenoid valve failure. Internal solenoid valves within the unit can fail. Long periods of inactivity. Some reports suggest that not driving the car regularly can cause oil to drain from the multi-air unit's galleries, leading to issues on startup. Solution: often, replacement of the entire multi-air unit is necessary. This can be a costly repair. Proper preventative maintenance with the correct oil is key to avoiding this. Spark plug and coil issues. Similar to any modern petrol engine, worn spark plugs or faulty ignition coils can cause misfires and rough running. Turbocharger issues. Less common than multi-air unit failures, but turbo problems, wastegate issues, bearing wear can occur, similar to the T-Jet. Timing belt-related issues. As it has a timing belt, failure to replace it at recommended intervals can lead to catastrophic engine damage. Fuel consumption. The 1.4 Multiair engines typically offer good fuel efficiency for their performance class, often better than the equivalent T-Jet. Official combined figures can range from 5.7 liters per 100 kilometers, around 49 miles per gallon imperial, to 6.5 liters per 100 kilometers, around 43 miles per gallon imperial, depending on the vehicle and power output. However, like any turbocharged engine, spirited driving will significantly increase real-world consumption. Timing. The Fiat 1.4 Multiair engine uses a timing belt. Replacement interval. The official replacement interval can vary, with some manuals stating up to 150,000 miles, approximately 240,000 kilometers, or 10 years. However, due to the critical nature of the timing belt and the fact that it's an interference engine, valves will hit pistons if the belt breaks. Most experienced mechanics and owners strongly recommend a more conservative interval, typically 80,000 kilometers to 120,000 kilometers, 50,000 to 75,000 miles, or 5 to 6 years, whichever comes first. It's crucial to replace the water pump and tensioners and idlers at the same time, as they are part of the system and significantly add to the labor cost if replaced separately later. Oil type and change interval. This is arguably the most critical aspect of multi-air engine maintenance. Oil type. The multi-air system is extremely sensitive to oil quality. Fiat and Chrysler and Jeep typically specify fully synthetic engine oil that meets a very specific Fiat specification, often Fiat 9.55535, S2 or Fiat 9.55535, GS1, for later multi-air 2 with direct injection. The common viscosity is 5W40, though some applications might specify 0W30 or 5W30. It is imperative to use an oil that explicitly states it meets the relevant Fiat specification. Brands like Silnia, Fiat's factory fill oil, MOTO, Leaky Moly, and Castrol offer oils that meet these requirements. Change interval. While manufacturer intervals can range from 15,000 kilometers, 9,000 miles, or 12 months to even longer, for optimal multi-air unit longevity, it is highly recommended to change the oil and filter more frequently. Many experts suggest intervals of 10,000 kilometers, 6,000 miles, or 6 to 9 months, especially if the car sees frequent short trips, heavy traffic, or spirited driving. Regular oil level checks are also essential, as low oil can quickly damage the multi-air unit. Some sources also recommend regularly cleaning or replacing the small multi-air unit oil filter. Overall opinion: the Fiat 1.4 Multi-Air engine, when functioning correctly, is a clever and effective engine that offers a good balance of performance and efficiency for its size. It provides a more modern driving feel than the older T-Jet, with better throttle response and typically lower fuel consumption. However, its Achilles heel is the multi-air unit's sensitivity to lubrication. Strict adherence to oil type and more frequent oil change intervals than generally recommended for other engines are absolutely paramount for the longevity of this engine. If you're considering a car with this engine, ensure its service history is impeccable, especially regarding oil changes. If properly maintained, it can be a reliable and enjoyable engine. Neglect its oil, and you're almost guaranteed to face costly repairs. Thank you for watching the video, and I invite you to subscribe to the MOTO Freak channel. Greetings to everyone, and see you in the next episode. See you soon.